One. Okay, guys. Hello, guys. Here. I'm Tony, and I'm gonna do the presentation of the Bitcoin mining with Tom. So here is the algorithm of the Bitcoin. So we use SHA-256 to hash C plus X, which is the input, twice. And if this input is smaller than our target, then we successfully mined a block. And this is range of X. X is the random number you guess. And C is depends on the Bitcoin, depends on the previous block. So to gather the information to calculate the Bitcoin, you need to go to the Bitcoin website, btc.com. And these are the latest blocks. So we click the first one, which is the most up-to-date one. So we can actually, mining, try to find the next block. So there are a few numbers we're going to use. The first one is version. The version is literally version, is the version of the Bitcoin right now. So we're going to use this number. And the next number we're going to use is the previous block hash. Here. So yeah, this is previous block hash. And next one is the Merkle root. This Merkle root depends on all the transactions and all the information contains in this block. So basically, it's also a hashed value. And the next one is bits. Bits is actually bits is our target, but we have to modify this one a little bit to get our actual target. And nonce is the random number we guess, which is X. So nonce is X. So this is his guess, and this one success, and this one success. And the next one we're going to use is time. Put your mouse here, you can see the UTC time, but we're going to just use the local time. The Bitcoin website will use the local time according to your system. Actually, we're not using this time. We're using the timestamp. Timestamp is the number of seconds from 1970, January 1st, 0 a.m. to now. So from that time to now, the number of seconds. So knowing all these stuff, we can calculate the hash value of the block. So we're just going to append, put this one first, and then append the previous block, and then append Merkle root, and then append bits, then append time, then bits, then your nonce. So just append these stuff to become a huge string. It's not actually a string, it's a binary string. So it's become a huge binary string, and we're gonna hash that. So if the result is smaller than the target, which is bit, you're a success. So the process from bits to target is like this. So this is our bits number, and we're gonna put this 18 to the exponential part, and this 1BC330 goes to the base part. This is actually a base 256 number. So 10 decimal is base 10, hex is base 16. So this is base 256. We're going to use the first two digits, 18 in hex, minus 3. That's our exponential, and we use 1BC000 multiplied 256. That's going to be our base. So the result is this number, this huge number. It's 256 bits. Our int is only 32 bits. Long is 64. So it's a huge number. Even though this is huge, it's still very hard for a hash value to goes under this number, because hash value is actually just random values, doesn't have any mathematical meaning. So to become like smaller than this number, they have to be starting with a lot of zeros. So this is starting with a lot of zeros. And then this number become smaller than the result, you get the correct hash. As you can see, the bits now is 17. And this example is a long time ago. So the bits started with 18. So this number is much larger than our, so this target is much larger than our target right now. So the process is actually getting harder and harder. And the reason for that is, actually we learned that in the class. The number of, so they want to generate a new block every 10 minutes, but because Bitcoin is getting more and more popular, so the people, more and more people is trying to calculate it, trying to mining the Bitcoin. So the time used to find a block is getting shorter and shorter. They have to add on the difficulties to compensate for that. So the block is like every 10 to 12 minutes. So you can see this is, yeah. So this is already like this is 5 minutes, this is 4 minutes, this is 10 minutes, this is 12, oh, this is 2 minutes. So we're actually pretty fast. People are actually pretty fast. Okay, so now Tom, we're gonna do the demo with Bitcoin. Okay, please, Tom.
Okay. So I'm sharing my screen. You see what I'm saying?
Yeah.
Okay, so the first step of calculating the block hash is actually going to the btc.com site. So we actually need a lot of values for this to work. So we just get the examples from what Tony just did. So let's fire up the program. Okay, so this is our program, and it will require the users to enter some values to be able to calculate the block hash and determine if the block is accepted or rejected. So first requirement is enter the versions. So here is the versions, and it exclusively said that don't include the 0x because we just have to sort it out anyway. So let's copy this one and put it in here. So the previous block is the block behind it, and this is the previous block you can on the website. So I'm just gonna grab this value and here. And okay, so the next step is the Merkle root. You can find the Merkle root in this line over here. So you can just copy it down. Okay. The next value that we need is the time. So the time on the website, we will want to use the local time instead of UTC up here. It's automatically changed to your time, and the algorithms in our program will also based on your local time to calculate the timestamps. So this is the format of the date and hours. So first we just turn it the 28th of April 2020, and then the time is 10:44 and 34 seconds. The next one would be the bits. You can grab the bits over here. So this is the the one that we use to calculate the difficulties. And so put it in here and it will output the threshold. This is an integers. So every time you it will automatically generate a hexadecimal threshold. And this is the integers you can see, a really large number. But the chance of the output is lower than this. It's quite hard to achieve. And the next one is the random numbers. So yeah, for the final output, it will output the Linux command if you want to check it yourself. So I'm running on a Linux machine right now. So it will automatically run this command and store it into a value. And
One.
Sorry for the pause. I'm running on VPN right now, so it will cause some problems with the internet. So after you enter the random numbers, you will have this output. And the first line you can see is the Linux command that the program already generate for you to try. So let me demonstrate. So right here, so is the output if you run this command. But you can see that it's a bit different from the block hash. This is because the output is big Indian, so we want to switch to little Indian. So this is after we switch to little Indian. And so what you can compare it to the online result of the block. As you can see here, this one is identical to this block hash. And because this is a accept block, it will say that congratulations, your block is accepted. And to be able to generate this message, the program will use this integers from above, from the bits that you entered before, and compare it with the hexadecimal of this number. So if this number is smaller than this threshold, then it will congratulate you for getting the block accepted. So that's the basic process. So I will demonstrate for when it won't be accepted. So everything will be still the same, but except one small changes. So like it's 8. So we still enter the same bits, but for the nouns, we can just try to change it to see if it's gonna get over the threshold. So for example, I want to change A to, let's say, F. So we become 15. So now, yes, you can see that the threshold is actually smaller than the int of the block. So which means this block won't be accepted because it is over the threshold. And it will just saying that your block will be accepted and you need to change the nouns. And so that's it.
Okay.
Thank you for.
So I'll be explaining a little bit more about this. So I'm gonna share my screen. So can you see my screen?
Yeah.
Okay. So it could happen that you use all the nouns because nouns is from 0 to this number. So if you used all the nouns and you couldn't find one single hash that is smaller than the bits, you can simply update the time, because the time is just the beginning time of you calculating. You start to try to mining, and it doesn't update every time you try the nonce. So actually, um, this is everybody's time could be different. So yeah, so basically you can enter anytime you want. The time here is just for referencing, like uh, so you won't be able to cheat because the Bitcoin client gonna generate the time for you. But actually, you can change the time to anything else and still get this block hash. Also, we cannot actually perform the calculation of mining because we cannot get the Merkle root. Merkle root is based on all the data in the previous in the block we are going to calculate. So the Bitcoin client gonna collect all the transactions online and process that into the Merkle root. Then we can start to hash. Also about this SHA-256 algorithm, the design of SHA-256 algorithm is very good for the circuit board designing. So there are already some chips on the market that can calculate billions of SHA-256 every second and very easily designed. So some other cryptocurrency, they are using some other hashing functions that is not so good for the circuit board designing, so that people cannot cheat on that. And I think that's probably why we can see something like this only like a few minutes, then you get a new block calculated. Okay, that's all. Thank you.
Nice.